Hello everyone. So this is video number 4 in our JavaScript playlist. In this video, we will see a very specific use case wherein the call stack will run out of memory. Now, if you haven't seen the previous videos in this playlist, I would highly recommend you check out the first three videos. That is about JavaScript engine, execution stack, and how we see the execution stack in the Chrome DevTools. Now, assuming that you have a good understanding of call stack, execution stack, and JavaScript engine, I will proceed with this video. So in the previous video, we discussed about how nested functions are inserted into the call stack and how they eventually exit the call stack. So let's do a brief recap of this. So let's say this is a call stack, and then we have nested functions. Now, what do we have here is the first nested function. The first function comes into the call stack, it remains there. Then the another nested function comes here, it remains there. The third nested function comes in and remains there. Fourth nested function comes in and remains there. Now, eventually, once the last function, it gets executed, that is when the functions start exiting the call stack. So let's say this function exited the call stack, it's executed. So once this is done, once this is returned, then the next function will be returned and this will be also exited out of call stack. And same thing happens with this function and eventually the last function and eventually the global execution stack. Again, if you don't understand this concept fully, I would highly recommend you check out my first three videos. Then this concept will become far more clear. Now, okay, let's get rid of this. Oh, not required. Let's draw another execution stack here. So now consider a use case wherein the nested functions keep on coming, and never exit. So what happens eventually? So eventually this call stack, this will have some kind of limit. So if this limit is exceeded, then your browser, your V8 engine will throw an error. Sorry, I can't store anymore. That means there's an error. So you can't proceed further. So your V8 engine, your call stack gives up and tells you, I can't store anymore. So now the question is why this kind of scenario might happen. Why there might be a scenario wherein there is no end to the entries in our call stack. So this can happen typically in recursion, wherein there is no check when the recursion has to stop. So let's consider a piece of code here. So it's a simple function, function recur, and it does nothing, it just calls itself. And if you see, there is no check here. It's gonna call itself every time. And every time it calls itself, there is an entry in the call stack. So every time this recur is called, there is an entry in the call stack. So recur is called, it goes to the control flow to line number 1. What happens again? Again recur is called. Every time recur is called, there's an entry in the call stack. And there is no check, there is no limit how many recurs I am putting into the call stack. And eventually what will happen? Call stack will give up, V8 will give up. So now let's see it in practice. So I'm loading this code in my browser and let's see what error I get in the console. Now, if you see, the error here shows range error, maximum call stack size exceeded. So what does it mean? What is Chrome DevTool trying to tell you? What is V8 trying to tell you? Hey, this call stack is exceeded. There is the range error. The range has been exceeded. I can't store anymore. Now, let's see what kind of error I get if I load the same code in my Mozilla. Internal error, too much recursion. So the root cause of the error is the same, but just the error message is different. That depends on the browser JavaScript engine, what kind of error message it throws when the call stack is exceeded. So in other browsers like Edge or Internet Explorer or Safari, you might get a different error, but you need to understand the root cause is the same, that the call stack has been exceeded. Now, what to do in this kind of scenario? So simply you might need to put a check. So let's say, how can I fix this kind of code? So let's say I have a global counter equal to 0. Now I put a check here. If counter is less than 10, then call recur. So that means this recur function will be called only 10 times. So once the counter is reached to 11, this recur function won't be called and there won't be any further entry into the call stack. I think we need to increment the counter as well. Otherwise, if we don't increment the counter, then we will again run into the same issue. Because again, the counter never increments. The counter is always less than 10, and there will be endless entries of the recur function into the call stack. So now this error should be fixed. Let's run it again. Okay, so we have the same error here. Let's see what's going on. Okay, I had to pause the video for a minute. So I found the error. So what's happening here is we are incrementing the counter after the function is getting called. So it's never reaching this operation line number 7, because at line number 5 only we are calling the recur function. So this is another use case wherein you might get this kind of error. So how we can fix this error is basically increment the counter before the function is getting called. So this should fix the error. Yes, it fixes the error. Let's try it with some kind of a log. Let's log the counter. Yes, I'm able to see the counter, so that should fix the error. And if I try it in Mozilla, and yes, it fixes the error in the Mozilla as well. So be aware of these kind of errors. It can happen sometimes in your applications and could be very hard to debug. But whenever you face such kind of issues, the very first aspect is an endless recursion. And now you know how to fix these kind of errors. So you need to make sure that there's a check on how many times your recursion is getting called. So thank you for watching this video. Do share, do like, and do comment for any queries, and do subscribe for upcoming more interesting videos. Thanks for watching. Bye bye.